Yeah, hello. I talk a lot about the architecture used in ancient modern, especially in sacred architecture, cathedrals, temples, memorials, grand public buildings, again, both ancient and modern. And they always have these same set of numbers in there, but I think this is especially if you're new to it, and I overload my videos with it, and for people who are new to it, it might be a bit heavy, but I want to have a look at and explain it how especially moon, sun, what I'm labeling as the temple of man. You could write New Jerusalem, you could insert the yugas, or you could also the Ark of Utnapishtim, so from the Epic of Gilgamesh, the great flood story, which predates the story of Noah's flood by quite some time. You'll find that actually throughout the Bible that it's basically a rewrite of the Epic of Gilgamesh. But begin with the numbers now. For instance, the number 108. That's one of the keys. It's one of the best numbers to get used to and to remember. And by 108, so we begin with 108, simply add a 0 on the end, and miles, and we have the equatorial radius of the moon. The next number, which is simply doubling 208, so we have, 108, so we double that, we have 216. 216 miles gives us the equatorial diameter of the moon. And so if we double 216, we get 432. Now, you notice that these ones I added a 0, so we just times it by 10, but now we're going to times it by 1,000. So we have 43,200 miles is the equatorial radius, of the sun. So 108, 1,080 miles is the equatorial radius of the moon. 2,160 miles equatorial diameter. So of course radius is half of the diameter, so we have 864 times 1,000 miles, and we have the equatorial diameter of the sun above 99.9%. And also if you do a first page search of the diameter of the sun, you're probably going to get 86,500 miles. Now, without going too heavily into that, that's defined, they're using the transit of Mercury across the sun to define where the sun's surface is. Now, the sun's a big ball of gas and it's bubbling and all that type of stuff, so it's always going to be a matter of not only margin of error but also margin of definition. How do you define the surface of the sun? Now, if you have a look at the eclipse, you'll find that the ratio is 400 in size and 400 in distance between sun and moon, and so therefore 86,400 miles is as good as a number as you're going to get, and also has to do with how they define the surface of the sun. So unlike the moon and the earth, which have a very clear surface, a very clear distinction between the surface and the atmosphere, or the sun is a little bit tricky in that way, but through the eclipse we can find that it's actually 400. So 216 times 4 is 864, and it's just a matter of how many zeros on the end there. So we started with 108 times 2 is 216 times 2, 432 times 2, 864. So the next number would be 1728, or 12 cubed, going nicely. But what's so important about the number 1728 and the Temple of Man? Well, the New Jerusalem, which is described as a cube of 12,000 by 12,000 by 12,000 furlong, therefore the volume of New Jerusalem would be 1728 0 0 0 0 0 0 0 0 0 furlongs. So, but this is cubed. So, unlike these being one-dimensional numbers, like a like a ruler measuring in one line, in one direction, one dimension, now we have a cubic numbers. But we also could think of that. So, if it's 12,000 by 12,000. That would also give us 1440, so 12 times 12 is, so in two dimensions you could also use the number 144, but that's separate. So what we have is one dimension, the three-dimensional cube, and now I should rub that out now. So we've just doubled 108, 216, 432, 864, 1728. And before I go further, the Ark of Napishtim, as described in the Epic of Gilgamesh, the edge length of the Ark is described as 120 by 120 by 120 cubits. So we get the same, so it would still be 1728 cubic cubits. So whether you're using furlong as described in Bible in Revelations, or if you go back to the more ancient source of the Ark of Napishtim and the Epic of Gilgamesh, you're still getting 1728 describing a cube. Now the next point is, so what is 1728 times 2? We have the same, so we have 3, 4, 5, 6, and if we double that again, we get 16, 9, 12. Now the interesting point about is that, so the sun and the moon are equatorial, but now, and in miles, but now, well, 3,456 is the polar diameter of the polar radius of the Earth in Egyptian royal miles. And therefore, the diameter of the polar diameter of the Earth is 6,912 Egyptian royal miles. So let me check, I'm going to be getting shot. Okay, so while we're here, so one Egyptian royal mile is 8/7 miles equals an Egyptian royal mile. And if we convert that, we'll find that the radius of the moon, equatorial radius, is 945 Egyptian royal miles. Very nice, because this number is a lovely conversion point, so we get whole numbers between these. So if it was a little bit either way, even if it was a whole, like 1090 for instance, we wouldn't get this conversion point. You're going to get decimals or fractions, okay? But therefore the equatorial diameter of the moon is 1890 Egyptian royal miles. The equatorial radius of the sun is 378,000 Egyptian royal miles. Therefore the equatorial diameter of the sun is 756,000 Egyptian royal miles. Now the southern base of the Great Pyramid is 756 feet, which is a nice tie-in. But so what we have is Egyptian royal miles convert, so, and these are one-dimensional measurements. So we'll skip across here, and if you're here, so we have 3, 4, 5, 6 Egyptian royal miles, and 6912 Egyptian royal miles. Now, unlike here where we've used miles, now we have to use Egyptian royal miles, because if you convert this into miles, you don't get this same pattern going on again. But we do have that happening here, but we don't have it happen. So when you convert to miles, it doesn't work the same. But there's a way also. Another way to think about, so the temple of man. So if I'll just do it. Little sketch, and we have, so here we have man, and so he's like, I think what's an interesting point is that we have, so the sun, the moon and the sun, man relates to them, he sees them rise over the horizon, and he relates to them via their equatorial diameter. Same thing with the moon. But the man or woman, I'm just using man as a general term, okay, he stands on the earth and he sees the sun and the moon by diameter, but he relates to the earth more in symbolically, at least in this way. So, we stand on the earth, we don't see it. And I think that's at least an interesting way to think about it. So we also have, not only do we shift from equatorial diameter when we reach the temple of man, we also, now we shift to polar diameter. So again, it's like this nice connection going on there. And more interestingly, we also have to shift units, so miles, and then in the temple of man, the units get shifted, and then we come to Egyptian royal miles, so miles doesn't work. The equatorial diameter of the earth is 7,920 miles. Now, I covered this particular number and how it relates to systems of measurement such as Gunter's chain, 66 feet being 792 chain, but also the edge length of New Jerusalem is 790, I forget the amount of zeros, but feet. So this number 792, the system does connect, but just to review, so 108, 216, 432, 864. We're simply doubling these numbers up, and it's just a matter of, do you multiply it by 10 or you multiply it by 1,000, and then we have miles. Then we come to the Temple of Man, or New Jerusalem, or the Ark of Napishtim as the Epic of Gilgamesh, and then we shift to polar diameter, and we also have to we'll shift units. So Egyptian royal miles carries through here, but at this point the system of doubling using miles doesn't work. For instance, half of that would be 3,960. So anyway, just a quick one, just at least. So at the very least, this now forms an interesting, a simple way to remember all diameters of the sun and the moon, and polar diameter or radius of the earth, and with the three-dimensional. In fact, remember these are one-dimensional numbers, but when the Temple of Man or New Jerusalem, Ark of Napishtim comes in, it's a three-dimensional number. And yeah, so it's okay, that's all in short. So at least that's a way to think about it. It's not necessarily the only way to do it, but if you're new to this system, you just got to remember. So the radius of, you remember the number 108, double that 216, double that 432, double that 864, and you've already got a good way of remembering the diameter or slash radius of sun and the moon. For the people interested in mythology, then again 1728, and the New Jerusalem cube as in the Bible, or the Ark of Napishtim. Now each one of these numbers is well, this one too, but I'll just to highlight those ones. These are also numbers that you're going to find in the ancient Hindu, in the yugas. So again, the amount of zeros is different, but you still have the same system. So ancient India, ancient Sumer or Babylon, the Bible, and and also modern systems of measurement, not including metric, but metric, strictly speaking, is not a modern system of measurement. There's more than ample evidence to prove that. But so at the very least, 108 times 2 times 2 times 2 times 2 times 2 times 2, and you have a very lovely system for memorizing a whole bunch of astronomical information, as well as and that the system works through ancient mythology as well. So yeah, that's basically it. That's like a good way to introduce yourself and remember that. So this, you remember one number, 108. That's all you got to remember. And then the rest of it is times 2, times 2, times 2. You have moon, sun, and earth, as well as the temple of man, which is, so unlike these, which are first dimension, this one is a three-dimensional number. And again, well, man relates to the world in 3 dimensions. So, and he sits, you know, on top of the earth, which is a nice way to think of the reason we have to shift unit why miles falls apart, but yet it still carries on in the Egyptian raw miles. Now, also as a thought, now miles, maybe you might think of them as astronomical numbers, and sort of, so avoid the word royal numbers and profane numbers. But anyway, that's it. Anyway, hope you liked it. Have a good one. Okay, while I'm here, I should add as well, so if we just do those numbers again, 108, 216, 432, 864, 1728, 3456, and 6912. These numbers all hold basically they're multiples of 9. So if we do, okay, the 9 times table, so 9, 18, 27, 36, 45, 54, 63, 72, 81, and 90. But here's any number that's multiplied by 9 will create a set of digits that are going to add up back to 9. So, you know, 9 times 2 is 18, 1 plus 8 equals 9. 2 plus 7 equals 9. 3 plus 6 equals 9. 4 plus 5 equals 9, etc., etc. So again, so 108, it's a multiple of 9. 9 is 3 squared anyway, but so, you know, 1 plus 8 equals 9. 2 plus 1 plus 6 equals 9. 4 plus 3 plus 2 equals 9. 8 plus 6 plus 4 equals 18, but 1 plus 8 equals 9. 1728, the same thing. The numbers that they'll add up to 18, or 1 plus 8. 3, 4, 5, 6 is the same thing, and 6,912. You've got the same thing going on there. So this technique is also used by, you know, mind readers and mentalists, and so they'll ask you to, for instance, you know, pick a number, you know, add 3, take away 2, and at some point they're going to say multiply it by 9 and then add those digits together, and they can always lead you back to that same number. So this is why 9 in base 10. So if you even think of base 10, 1, you know, plus 2, you know, so we go up to 9, and then we have 10. So what when we say 10, what we're really saying is a new series beginning at 0. So 9's the highest number, so to speak, and when we reach 10, we're just almost like an abacus, or, you know, counting with beans. We just start a new column. And now that's in base 10. Now the same thing's going to happen with, say, if you're working in base 12 or other numeration systems, the same thing will happen again to their, you know, highest number in that numeration system. But since we all use base 10, that's what makes the number 9 so special.